Hi again, Adrian back here on the Sofeast podcast, and I'm joined by Andrew again today. Hi, Andrew.
Hey Adrian, how you doing?
Yeah, I'm good. How are you?
Excellent, thank you. I'm excited about today's topic.
Yes, thanks for coming back on. We really need somebody who's got a focus on reliability for this one. Well, this is episode 165, by the way. And the reason for getting you on is because we're going to look at a scenario, right? Let's say that you have launched your new product. So you've gone through all of the product design, product development, and, this has taken a lot of time, a lot of money, perhaps, and you've got it selling on the market. Everybody's happy, everyone's excited. But suddenly you start getting product returns coming in, and your customers have got various complaints. Maybe the product is not working as they expect. Maybe there are some other issues, that maybe quality problems, perhaps, or something like this. But one thing we know for sure is that customers are returning them and they're not happy. Okay. So in this scenario, which we absolutely do not want, we want to avoid, right? But if it happens, who are you going to call, right? It's not going to be the Ghostbusters. It's going to be somebody more like yourself, right? So you're going to do, you're going to take us through this scenario and talk about how you find out what's going on, and then basically find and fix the problems and solve it. So and ultimately come to a positive outcome. So yeah, I suppose if we start off with, you've got a product which is on the market and you're getting returns, what is the first step, please, Andrew?
Well, I like the way you talked about who you're going to call Ghostbusters, and well, in this case, honestly, if you had a big company with different departments and you have a reliability department, everyone is going to go after the reliability team. They're going to be
Mm,
like, okay, we've got a huge return and we have no idea what to do. But if you're a small company, one man operation, and or you got a few team members, but really no one is dedicated to reliability engineer,
yeah.
things could be very, very difficult, because that's when you call us. And
Mm,
we have those kind of services, right? We have reliability engineering services that we could actually help. But if you're a medium to large company and you have a reliability team, you probably are going to assign at least one reliability engineer for this particular project,
mm,
that is experiencing a huge return rate, customer complaints, and so on. And to address this issue, the reliability engineer assigned to this project most likely need to attack the returns and need to understand the first step. What is the issue? Why
mm,
are these products are being returned? And in doing so, there are a number of tasks that a reliability engineer may do. One of which is a triage. So you got these products, piled up in a room with all kinds of issues, and nobody knows what to do with them. So the first thing to do is identify the issues. But identifying the issues is not that easy. All the products are in piled up in a room. They call it returns, and you probably need to assign another team to work with the reliability engineer, and this team will be considered a triage team, a team that is going to separate each one of these failures, whether there are manufacturing related failures, component related failures, and customer complaint return rate related, and then you go deep dive in those customer returns, again the same way, whether there are component related, manufacturing related, and or design related issues, if you can identify those. Once you identify those and you categorize those, then there's another thing that the reliability engineer needs to do. He needs to start tracking the data. What is the current, like today's return rate? What is it tomorrow's? So on a daily basis, the reliability engineer will track how many returns are coming. I mean, literally on a daily basis, he would log in. Okay, we got one more today, and this one is related to, for example, component or display related, or the battery is not charging, and he will be logging these on this database. And as he's logging these on the database, you can actually do some charts and graphs too to see, they call it trend analysis, to see if the returns are increasing day by day or decreasing, and what are the main issues increasing. For example, main issues are display related, and display related issues are increasing day by day. Yes, you have a battery issue, but it's just like, you know, you had one today, one like 6 months ago and one today. That's just not a trend. But if you got one display today, tomorrow another two more, and the next day three more, and so on, that's increasing trend on one failure mode alone. So that will be a very eye-catchy type of situation. And basically, reliability engineers' role is to bring out these issues, show to the team that, you know, which ones are the urgent issues that needs to be attacked, and then understand the customer pain points, and you know, come up with a corrective action plan and fix these issues. But identifying the issues firsthand is totally critical, because you have to come up with data to the management to get management support on actions that need to be taken. Because maybe management doesn't understand how big the issue is. You know, for example, if you've got battery issue, right? Then we're talking about possibility of explosion, fire, loss of property, huge lawsuits as a result of battery. Remember, we talked about in the past, you and I, about what happened when there was a battery issue with one of the Samsung, what was that, mobile phone, I believe?
Yeah, Galaxy Note 7. It's the famous case of the exploding smartphone that basically it nearly took Samsung down, I suppose.
Exactly. So that sort of issue needs to be headlined within the company to the management immediately, that we have a unsafe situation with our product. We don't take care of it. Even if it's one time happening in every month, it's still very important issue. So from reliability point of view, the engineer needs to understand, okay, when we're talking about identifying the issue, what are we talking about? Are we talking about a safety issue? Are we talking about an issue that really does not cause any customer pain, just kind of like a nuisance? Or is it a very critical issue, like the device, for example, powers down and the customer has no way of powering up? That would be not good. Or the display has lots of lines and, you know, flickering screen or something that pretty much annoys the customer to a point that they want to return. So those are the issues that the engineer needs to identify. And then actually another thing that would be really good at the end of these tasks, identifying the issues, is to create a Pareto of the issues. And when you are making a Pareto of the issues, you're basically tallying how many of display issues, how many of the battery issues, how many of component issues, and so on. And then you'll be able to see right away that you've got 80%, 20% issues that causing 80% of the problems. Yeah, Pareto.
And to be clear, you're talking about the Pareto analysis.
Correct. Yes. Yeah. And in doing so, it will help the design team or a team that is going to address these issues. It would help them to understand, okay, well, it looks like these first three or top three issues or top five issues are the most important ones that we need to address first before, you know, addressing any other ones if we have time, right? So I think that identifying the issue is the first step, but it's also the most important step on kind of organizing and coordinating the
Yep.
actions to come.
Yeah. At this point, I'll just jump in quickly, right? Uh, when we have a product that is in the field, so it's being sold on the market to customers, not every issue that a customer faces is going to be reliability related. But is it fair to say that if you do start getting customer returns, for example, they're probably reliability related at this point?
Very good question, actually. I think that you're right. Not every return is a reliability issue. More often, and again, it depends on the product, right? But if we're speaking of electronic product,
Mm,
once in a while, customers will receive an electronic product as a gift that they really don't like and don't care for.
mm,
And they will just return it just because they don't want it, not because there's anything wrong with the product. And that's where, as I mentioned, the triage team come in. The triage
yeah.
team will actually power up the unit, turn it on, check the software, performance, check the software version, and they will actually do what they call diagnostics on the
Yeah.
device. And the diagnostics will check everything, and we'll check, for example, for the display, for the health of the battery, and so on. And the diagnostic will come in and say the device, the whole product passed without any issues. Then we know at that point that product was just customer just didn't really want the product, not because there was any reliability issues with the product. And so
Yeah. Yeah.
that type of product, as you know, they will do a quick refurbish, check everything, update the software, and put it back in the box again and resell it. However, we're talking about a customer that opened the device and actually used it for 2 or 3 months, and all of a sudden, for some unknown reason, something happened. Either the product didn't charge properly, operate properly, something happened. And again, to be honest, between you and I, sometimes some customers would actually drop the device
Oh, yeah.
and hurt the device in some ways. So the device performance changes after you've gotten either water into it or dust into it, or you've dropped it from a high height. And these kind of situations would make it very difficult for manufacturing to determine whether or not this was a customer impacted device that caused the device not work, or was
Yeah.
it a truly a design issue or manufacturing issue or a component issue. So yeah, those are the kind of things that goes into triage, and engineers and the triage team talk about a lot about, well, what do you think? Do you think the customer caused this? Because there's no way this failure we've never seen before, for example. So if you've never seen a failure and it's only one of a kind in the whole returns, clearly that is a customer impacted type of issue. And
Yeah.
most often, when the engineers are taking data, they would actually discount that one point in the data. They will say, well, this seems like off, doesn't seem like part of the trend, so let's just not count it, and
Mm,
let's just give one device for this guy and get him off our back, because it's not our fault, basically.
mm.
However, when you have a real return issue, you will have more than one. More than one customer will be complaining, more than one customer will be returning, and every time you're testing, you will see exactly the same failure mode. Then you
Yeah.
know you have an issue. Like you've seen in the car companies, right? All of a sudden, airbags are not inflating properly. Somebody's dying from inflation of an airbag. And at the beginning,
Mm,
car companies are trying to analyze, investigate. And during the investigation period, they're not really giving out the news that, oh my God, somebody died from an airbag,
no.
because they're really not sure what's happening. But once they figure it out, they will have a recall. because they know that it's their problem. It's not
Hmm.
the customer causing the problem. It's
Yeah.
not because customers, for example, knock another car when they're parking, and
Hmm.
they actually cause the airbag to inflate and trigger.
Hmm.
So I'm just giving a wild
Hmm.
example, but identifying the true issues and having a Pareto analysis on that is critical.
Okay. So that's kind of step one, and that's a logical first step. So what's
Right.
actually going on? So if we move on to step two, then, right,
Right.
we found legitimate issues, not a customer has returned a product because it was an unwanted gift, but there is literally a problem, i.e., a product does not turn on properly. Okay. So what are we going to do now?
Well, the second step, determine, what the root cause of the issue is. So you've got a pile here that you're calling it, okay, it's all, for example, display related issue. There's another pile here. When we say triaging, that's what we're saying. We're just piling and categorizing and separating and putting all the issues that are similar in one pile, and
Yeah.
different issues in another pile, and so on. So now that you have these piles, but we don't really know what caused these display issues, for example. So you need to start somewhere, right? And one way is you distribute these piles to different engineering teams. Maybe you send one to production team and say, hey, can you check and see if there was any production issue with this display? And then you send another one to engineering team and say, hey, can you check and see if this display supplier is approved supplier, then the component is an approved component, and whether this was a new component or not a new component, what can we do about this particular component as a display? Then you send it to another one to design team and say, well, hey, can you check and see whether or not the circuitry that was this component display was working with is all good, and why is this failing? Can you check and see if you find any issues? So all different kinds of teams are actually working, and finally someone will find an issue, will find the root cause. Root cause could be, for example, we're talking about display for a phone. What would be the number one reason if the display is cracked?
Oh, well, my guess would be people are dropping it.
Exactly, right? I mean, that's a very simple, obvious reason, right?
Yeah.
But you can find what the root cause is. Well, okay, the user dropped it, and so now we're gonna do a display change, right? We completely, you know, come up with a brand new display. However,
Mm.
what if there was other issues, not necessarily for iPhone, but I mean, let's say the user is turning on the device, whatever the electronic device is, but it's not waking up. It's not turning on. Well, what's the problem? Is it because the battery connection is messed up? The circuitry, something fried, a component fried? Why is it not waking up? So that could get really complicated. And then that's where you have the software team update the software, see if that fixed it. Usually that's the first thing they would do. Next
Mm.
thing they will do is take it to engineering. Engineering will actually connect it to all these network analyzers and all kinds of test equipment, and see if they're getting the right signals, right current, right voltages. And if they're not getting something right, they will say, well, okay, I'm supposed to be getting 10 volts here. I'm getting 9. I'm supposed to get 5 volts here. I'm getting 1 volt. Something is wrong. And,
Mm.
and they will start investigating it further. So whatever the issue is, they need to find the root cause. If the root cause is not determined, they won't be able to know what the problem is and what they need to do to fix it.
Yeah, makes sense. Okay. So now that we found the root cause, what do we do next? I mean, I assume that we need to find a way to fix that problem.
Exactly. So, okay, now you know what the problem is, then you need to fix it. So you need to
Yeah.
come up with a plan. So develop a solution plan, develop a plan how to fix it. But remember, you're not just trying to fix it for this one unit, right? You're trying to fix it for all future units so that this problem doesn't come back again. The whole idea of corrective action plan, which you should have, that's also another word for determining a solution, is that you need to have a corrective action plan. This is basically a very standard way of discussing it, and a lot of electronic engineers know this corrective action plan. In some other industries like airspace, they may call it fracas, failure and the corrective action plan and so forth. It's a little bit more in-depth analysis of the issue and having a plan for it. So the issue with this corrective action plan is that you need to have a team organized, and you need to look at each one of these issues. Then you need to assign the issue to a team. The team goes and works on it and comes back with the root cause analysis and corrective action plan. Then you take a holistic way and you create a database that shows, okay, we had this issue and we implemented this action, corrective action on this date, for this project. And then now it's going to go to the next level, right? And the next level after you implemented the corrective action plan is to monitor it, right? To see, okay, now that we have, actually, I'm jumping ahead a little bit. Now that you have a solution planned, the next thing is work with the team to implement it. So you might actually work with various teams, not just one or two. Somebody in marketing has to calm down the customer, for example, and say, hey, sorry about that. We know what the issue is. We're going to fix it. In the meantime, we're going to send you a brand new unit, right? And then someone else in engineering is ordering new parts, new design. It might take 2 months to redo the whole design. And then manufacturing is waiting for new stencils, new orders of parts. And so there's a whole team working on the implementation, which is the step 4, right?
At this point, I have a question though, right?
Right.
Let's say that you've received some product returns and they're not an isolated case. So there seems to be a recurring problem, which we're working on at this point, right?
Yes.
So while you're implementing the solution that you've developed, so that might be, that you have to use a different component or redesign something. This is going to take some time. If we know that we have this problem, as a business, do you stop selling that product? Do you take it off the market? Like, what do you do? Otherwise, presumably, you're going to get more customers that are going to experience the same problem.
That is a wonderful question. And that is something that the business deal with all the time. So it depends on the nature of the failure, right? So if it was something like Samsung, the battery's explosion, there's a safety hazard. Absolutely, you don't ship any product. You kind of put a stop ship on the product. But if it is something like there's a small little something on the screen flickering, but it's like way down at the bottom, most people don't even notice it and don't complain about it. But it's something that some people don't like it, and as soon as they buy it, they return it. So, okay, though that is not an immediate stop ship, but you try to, at the time of shipping that product, you check and screen for that issue. And if that issue is there, you just don't ship it.
Right.
Yeah. And
Yeah, that makes sense.
Yeah. However, if the issue is very big and it's happening 100% of the time when you are, at the final test, you see it 100% of the time because it's a design issue. It's a total failure of a design. And in that situation, I definitely recommend that you do a stop ship. because you're not going to be screening out that problem.
Right, right. Yeah, yeah. Okay. I mean, what you're saying makes sense because, of course, you can't take this action until you know what the problem is. So I suppose while you're working on the problem, that's a decision that you've got to make. So yeah, that's clear to me now. Fine. So we got to you're implementing the solutions that you've come up with. Yeah. So let's talk more about that.
Well, so implementation, as I said, is probably the most critical part because
Mm.
it takes a lot of resources in the company, and in some cases, it takes a lot of money. You have to reorder, redesign, remanufacture certain parts. It's a huge undertaking. And if you
Yeah.
don't have someone knowledgeable, a really good reliability engineer who knows how to coordinate these teams and assign actions. And I'm not saying that reliability engineer must do all of these. The role of the reliability engineer in this case, and some may disagree with me, and that's okay, because different industries have different way of taking on tasks, and some reliability engineers are in charge of more responsibility than some others in different industries, right? Like I
Yeah.
know for a fact that in some airspace engineers, system engineers, they really do a lot more than in the commercial industry. And so, on the other hand, in some industries, quality engineers are in charge, and they really do a lot. They basically drive the entire product quality, including reliability issues, including field returns and customer issues, and so on. And so, I want to definitely mention that it could be any engineer who is brave enough to take this task and actually drive it all the way through and get it done. And
Mm.
implementation is the key. And implementation not only involves dealing with different facets, different teams in the company, but also it includes a lot of documentation. And that documentation could be corrective action plan. It could be 8D reports that you have to send to your customers. It could be some legal documentation that needs to be done. I mean, it could go on and on. Implementation is not easy. Again, it depends on the industry, on the type of product. It could be something related to legal issues that the legal team has to take on. And so it's really a huge undertaking, and it takes the whole team to work together very well to be successful.
Yeah, I mean, it's a complex process. Yeah, as we've talked about before, of course. And with this as well, you're really pushing hard to get it done as soon as possible so you can, be selling products safe in the knowledge that they're not going to have these issues that are causing the returns. So I guess
I am
you've got
so
that
glad.
extra urgency as well, right?
I'm so glad you mentioned that sense of urgency is critical. Whether in a world that we're living in, where everyone communicates with each other online quickly, the word goes around very fast if you have a bad product.
Mm.
Almost overnight across the world, everyone knows, hey, don't buy this product. It's no good. Oh yeah, I bought it and returned it right away. So it's very critical, like you said, to have sense of urgency. And I would say one of the most important things that you would do right after the triage, and you're looking at all these issues that are happening, like top 5 issues, then you would put a notice that everything coming out of the production line must go through screening these top 5 issues. And if they find
Mm.
any of those issues, don't ship that product.
Yeah, yeah. Okay. So we've implemented the solutions that we've come up with, and we are now reselling the product, and we think that it's okay. So the final step.
Right. So number 5, final step is monitor what you have done so far.
Mm.
Monitor the results. So let's say you had component issues that you have fixed. You had manufacturing issues that you have fixed. You completely redesigned one of the PCBs, and you've retested and everything looking good. And then you run some reliability test and compliance test again. Everything is passing. Now, what you need to do is really the final step. Let's run some product. Let's do new manufacturing, totally new build. And at that point, you don't want to run a whole big, build. Maybe 5,000 units is good. In some cases, if the units are not so expensive, maybe 10,000 units is good. So you run some units and maybe you have an ORT plan, ongoing reliability testing, that it takes place the first few, 100 or maybe the first 1,000 units that come out from this improved units. And then you take some samples and you run ongoing reliability tests and to find out if the reliability changed per environmental conditions. And then, of course, you run them through some maybe user experience test to see if any one of those users found an issue that you couldn't find during the final test. So you basically go through a whole bunch of monitoring. You monitor your lines through the assembly line. You monitor your final QA and final test. And then when the shipping is happening, you make sure that there is proper AQL is happening. And if at any point of this process, anyone finds any issues that relates to, let's say, top 5, top 10 that you had identified initially, that means something went wrong and the process did not get improved. But on the other hand, nobody found any of those top 5 issues through the whole process up until the point of actually shipping, then you've got a success. Then the next thing to do is ship the product and then just wait in line, wait patiently to see if customer is going to come back and either complain or say something good about the improvements.
Yeah, and then hopefully not go through the same process again because everything's all right. But I suppose we're not going to get 100% fine, are we?
Yeah. I mean, that's the risk that you take. And one more thing that I want to add in here, reliability engineers contribute, quality and reliability engineers really contribute a lot to product development and manufacturing. But one of the things that they need to do is make sure that they regularly communicate with the customers and stakeholders and make sure that they really understand the customer pain and customer issues. Then, of course, internally, they need to work with all the team members, design team, purchasing team, manufacturing team, quality team. They need to work together well as a team. And instead of finger pointing and blaming anybody, just try to work together so that a common goal, fixing the product. And then, of course, stay up to date with the industry, latest standards and in reliability testing, latest finds on different components issues that are happening in this industry, or issues with certain suppliers that maybe they didn't know about, that they bought a component from a supplier that everyone is already complaining in the industry. So you need to be in tune with the news in the industry and see what's happening.
Okay. Yeah, absolutely. Let's just go back over this very, very quickly then, right? You've put your product on the market. Great. Exciting. Excellent news. But then you're starting to receive product returns. So you've just gone through the process of basically who's going to deal with this and how do you do it? And as an importer, I suppose you're hoping that you don't have to go through it. But unfortunately, reliability issues such as some of the ones that you've mentioned are probably fairly common in the life of a business. I mean, it's going to happen. You mentioned automobile recalls, right? I don't know if you've ever had a car recalled, but I have. And
Yeah.
so, and I mean, that's to the quite extreme case of it. But the good news is you might not need to stop sales completely as long as you're fixing whatever the problems are quite quickly and you're screening the products when they're going out in the meantime. So, we're not talking about full product recall. We're not talking about, stopping the factory. We're just talking about how to find and fix the problems and the role that reliability engineers play in that. So it's really good. And I'm pretty sure the listeners who are launching products or who've got products on the market, it's good to know this just in case, isn't it, Andrew?
Yeah, and there's one more thing I want to mention here to some of our listeners, because everything that we discussed today is, well intended, and many of our medium to big companies who have a reliability engineer, they either know some of this stuff or they will address it, maybe not in the in-depth, kind of a detail that we mentioned, but in some form or another, I'm sure they address it. But
Yeah.
what about some of our listeners that are one-man company or a very small team, or they have a team that does not know much about reliability testing, or even
Mm-hmm.
development tests, and they are doing private labeling, and they're buying product from China and just shipping, and all of a sudden they have huge customer complaints. What should they do? Well, in
Yeah.
those kind of situations, even if you are a medium-sized company, but you really rushed to market, didn't do much development testing, reliability testing, or didn't, have a reliability engineer, because you have a good engineer who's doing a great design, and somewhere in the line you guys said, well, we tested everything passed. Let's just go ahead and ship the product. And now you have a different picture. Your
Mm.
customers are complaining, and you have all kinds of issues. What should you do? Well, in Agilian and Sofeast, this is exactly why we are here in China, and we can actually help you do everything that we just discussed today. Perhaps if you don't have a huge amount of failures, now we're talking like thousands of thousands. But if you have a small amount of failures, we could help you with. When I say small amount, it could be maybe 1,000 or 2,000 units returned, something like that. We could help
Mm-hmm.
you with the triage. We could help you with the corrective action plan. We could help you with identifying and root causing the issues. Of course, these things could be time consuming, but you didn't do your homework before you ship the product, so you have no choice now. Basically, your options are limited right now. You can either basically shut down the company and don't ship nothing,
Yeah.
or
Yeah.
call us and we'll help you.
Right. Well, when we talk about doing it, though, this sort of remedial work is ultimately more cost effective than continuing to suffer from product returns and reputational damage and, the costs of fulfilling your warranty and all of the rest of it. But ideally, yeah, we want to avoid it by going through extremely thorough reliability and quality testing and compliance testing before we even put the product on the market. But accidents happen. They do slip
Yes.
through the net, and that's the scenario that we're talking about here.
I
Yeah, I
want I
mean,
want to
good.
I want to make a point here. If you have a serious issue that could be either a
Yeah.
safety issue, battery issue, or something that is going to tarnish, like you mentioned, your image, brand image,
Mm.
those are the kind of things that cost a lot because it's serious stuff. But if they're small, annoying things, and or things that, yeah, you know that the customers are not happy, but the percentage of the returns are low. You're getting maybe let's say 5 to 10%. That's not really low. Don't get me wrong, but
Yeah.
if your volume is low, 5-10% is not huge. But if your volume is high, even 1% is a lot. So it depends on your volume, and it depends on the complexity and the seriousness of the issues. And it could be something really easy that we could fix, and not cost much.
Yeah.
It could be something really hard to find or important and serious issue that maybe you have to completely redesign your entire product, and that could be costly.
Yep, absolutely. I understand. So good reminder to everybody. And although we hope it's not going to happen, if it does, now you know what to do and who to call.
Exactly.
Yeah, and it's not the Ghostbusters, by the way. It's the reliability engineers. So yeah. Okay. Thanks, Andrew, for coming on for this one. Helpful advice. And as ever, we will be back with another podcast episode next week.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.